Okay, so planes fly across oceans, right? No landmarks, no GPS, just water, for thousands of miles. How did they not just get lost? Like, genuinely, how did a pilot in 1950 fly from New York to London and actually land in London? How did they know where they were? How did they know which direction to go? And how did they not just drift off course and end up in, like, Norway? Because here's the thing, you can't see anything. There's no signs, no roads, just endless ocean and clouds. So what were they doing? Guessing? Using a compass and hoping for the best? Turns out, kind of, but also not at all. Okay, so the simplest answer is dead reckoning, which sounds way more ominous than it is. You just calculate where you are based on where you started, how fast you're going, and how long you've been flying. Easy, right? Wrong, because wind exists. You think you're flying straight east at 300 miles an hour, but there's a 50-mile-an-hour crosswind pushing you north. So now you're not where you think you are. You're off, and over an ocean, being off by even a few degrees means you miss your destination by hundreds of miles. So dead reckoning alone? Terrible idea. Pilots knew this. They weren't idiots, so they didn't just rely on math and hope. They checked, constantly, using the sky. Wait, the sky? Yeah, stars, the sun, the moon, celestial navigation. Imagine the stars are just a massive fixed map above you. If you know which star you're looking at and measure the angle between that star and the horizon, you can figure out your latitude. Do it with 2 stars, you get longitude too. Boom! You know exactly where you are. Pilots, or more accurately navigators, because yeah, there was a whole person on the plane just for this, would use a sextant. Same tool sailors used for centuries. They'd sight a star, do some quick math with tables they carried, and get a position fix. But here's the weird part. This worked during the day, too. They'd use the sun, or they had these special periscopic sextants that could somehow spot stars even in daylight. I know, sounds fake. It's not. Okay, but even with star fixes, you're only checking your position every so often. What if you drift between checks? Good question. Enter radio beacons. So starting in the 1930s, there were these ground stations that broadcast radio signals, low-frequency stuff that could travel hundreds, even thousands of miles. Pilots could tune in and the signal would basically say, "Hey, you're this direction from me." These were called NDBs, non-directional beacons. You'd point your plane toward the signal, fly toward it. If you had 2 beacons, you could triangulate, cross the signals, know your position. Later, they invented VORs, way more precise. These let you follow specific radial lines coming out of a station, like spokes on a wheel. You'd fly along one spoke until you hit the next station, then switch, hopscotch your way across a continent. But remember, we're talking about oceans. There's no ground stations in the middle of the Atlantic. So what then? LORAN. Okay, this one's cool. LORAN stands for Long Range Navigation, and it's basically the grandfather of GPS. You had multiple stations on coastlines, say one in Canada, one in Greenland, one in Iceland. Each station sends out a radio pulse at a precise time. Your plane picks up the signals and measures the tiny time difference between when each pulse arrives. Since radio waves travel at the speed of light, that time difference tells you your distance from each station. Do the math, and you've got your position, even thousands of miles out at sea. It's like if 3 friends yell at you from different corners of a dark room, and you figure out where you are based on how long it took you to hear each voice. Remember this for later. Because LORAN was great, but it still required external signals. What if those stations went down? What if you flew somewhere with no coverage? That's where inertial navigation comes in. This is the really clever one. Imagine a system that tracks every single movement your plane makes, every turn, every acceleration, every climb. It uses gyroscopes and accelerometers, basically the same sensors in your phone, to calculate exactly how you've moved since takeoff. No external signals, no stars, no radio. Just pure internal tracking. You tell it where you started, and it counts every step, continuously, for hours. The downside is, it drifts, slowly, because tiny errors accumulate. After a few hours, you might be off by a mile or 2, but honestly, for a transatlantic flight, that's insanely good. And here's the kicker. Pilots didn't just pick one method, they used all of them at the same time. Dead reckoning to estimate, celestial navigation to confirm, radio beacons to correct, inertial systems to fill the gaps. They'd cross-check constantly. If the stars said one thing and Loran said another, something was wrong. Fix it. On long flights like across the Pacific, there'd be a dedicated navigator sitting at a little desk with charts, sextants, calculators, doing math the entire flight for hours just to make sure they didn't end up in the wrong ocean. Which sounds exhausting, but it worked. Pan Am flew across oceans in the 1930s, routinely, accurately, without GPS. So yeah, next time you're on a plane watching a little dot move across a map on your seatback screen, just know that 70 years ago, someone was doing trigonometry with stars to figure that out. Wild.